Okay, we're live. All right, this is Chris McCord, and we have Chris Molozian on with us today to talk about his Diver Elixir project, which integrates with HBase, and how he's using that with Jinterface to integrate Elixir and Java. So thanks for coming on, Chris, and I'll hand it over to you, and you can tell us all about it.
Perfect. Thanks for inviting me to speak, Chris. And this is my first hangout, so if things go a little bit astray, then just send me a note and we can get it working properly again.
Yep.
All right, so I'm going to figure out screen sharing here. Okay, I'm back, and I can now screen share.
In Safari?
Yeah.
So Google Hangouts works best on Safari.
Yeah.
All right, I'll take it.
Yeah, I guess so. Can you guys see this?
Okay, yeah, cool. I'm going to check some settings here so I stop interrupting the video once I start talking. So.
Okay, so you see the main kind of opening slide for the presentation bit.
Yep.
Okay, cool. So let's do this then. Alrighty.
Cool. All right. Have at it.
Thanks. Okay, so first of all, some caveats. I am far from an Elixir, Erlang, or OTP expert. Picked up things incorrectly along the way. Please do let me know afterwards or tweet at me or whatever if anything I've said is inaccurate, and I can always fix it in the PDF later. So what I'd like to do today is talk a little bit about Jinterface, which is a piece of technology that ships with the OTP distribution, what you can do with it from Java, and a project that was kind of an experiment of mine to give the Erlang Elixir world at least the beginnings of a HBase driver that we can build on and turn into something very mature and high performant, without having to rewrite large swathes of Java code imported into Erlang and Elixir land and do all of the work necessary to communicate with Zookeeper and everything else involved with working with HBase. One thing that this talk won't cover is HBase itself in much detail at all. I will pause briefly and mention a small amount about it, but mostly in the context of what it takes to write a client driver for HBase. And this is something I'm still figuring out, still learning at the moment. Okay, so a small bit about me. I'm a platform engineer at Orchestrate. It's a Portland-based startup, been around just under 2 years now. We're building a NoSQL database as a service, which is a multi-tenant query platform with a single REST API. So you're able to query with a variety of different database technology, but you can access it as though you were talking to one single database engine. Before that, I was a client services engineer at Basho Technologies. A lot of you guys in the Erlang community will know Basho. That was where I got my first exposure to Erlang, and I did a lot of stuff from a maintenance perspective working with React, not from a engineering perspective directly. So I wasn't part of core engineering, but I worked with clients, and we were remotely connecting to Erlang shells running React to debug things and bits and pieces like that. And finally, I'm an Elixir enthusiast. I haven't put any Elixir code into production yet, but I would like to very soon. So plan of action. A little bit about Jinterface, a bit about distributed Erlang, a bit about Diver and the rationale for the project, and then what I'd like to mostly focus on is a bit of a code walkthrough, talk through how I'm connecting and starting a Java node from Erlang, and how I'm supervising the related linked process and everything that's involved with that. And finally, a little bit about future work for the client driver. So Jinterface hasn't been around all that long. Initial release was 2009. It sees the odd update from the OTP team. It's just recently got map support, but I don't think the map support has actually landed in the release that's on Maven Central yet, but it's likely to soon. And the Jinterface jar itself, so if those of you unfamiliar with the Java ecosystem, the packaging model is this jar concept, which is just a zip of, much like an e-script in Erlang, a zip of the class files that get loaded into the VM at runtime, and that jar is available with the OTP release, so you'll be able to find it in one of the lib directories as part of the distribution that you install, probably through Brew or whatever package manager you're using with Linux. So the purpose of Jinterface is to allow Erlang nodes to communicate with Java nodes. The mechanism for doing that is actually an implementation of the Erlang distribution protocol. So it allows the Java node to speak Erlang, distributed Erlang speak, and therefore communicate with to some extent with an Erlang cluster. Now, there are limitations with it, I think mostly from an implementation perspective, but I'll mention that in more detail a little bit later. Most important parts is that it does all of the work of handling that communication of taking Erlang term format and converting it into Java types, hey,
Chris,
handling that serialized. Yeah.
Can I have
Can you
real
hear me
quick?
okay?
Yeah, sorry, I lost all sound, but I think I'm good on my end now. So I can only see your expanded view of your slides, not like a focused, zoomed in look.
Oh, I see. All right. Okay. Then, wow. Okay.
Sorry
Let me
about
just
that.
switch. Yeah.
My
Let
audio
me
cut
just
out
switch.
for the last 2 minutes, so
Okay. Where am I? I'm going to Java Elixir data presentation PDF. So what if we do it this way then? Will you be able to see it? Can you see that?
so like whatever screen, I just see an overview of presentation with all the slides. So if you can just either use that as the display or
Yeah, it looks like I'll have to. All right. How about that then? Is that going to work well?
I'm still waiting for it to change here. All I see is a Jinterface purpose is
Yeah.
just highlighted, but it's not actually zoomed in there.
So you can't see that yet. Is that better?
1 second. So I'm the only one that lost audio, so at least everyone else was hearing. So we have you now. You're not screen sharing anymore. So we're
Okay.
good
How
on
about now?
audio. We just got to get the right screen. There we go. Perfect.
All right. Okay.
Okay,
All
we're
right.
all set.
You can clearly tell that this is my first Google Hangout.
No,
Um,
this is
uh,
my this is my 12th, and it's always like this. So this is par for
okay.
the course.
Uh,
All right, go at
okay.
it.
Cool. So let me just. So where were we? So Jinterface ships with the OTP distribution. It's a jar file that you add to your projects like any other jar package, and it does all the work of deserializing and serializing between Java types into Erlang types, and communicating them across the Erlang distribution protocol between nodes. So that's the main purpose of Jinterface. It was originally designed, and I think it's actually, I'm using it for the purpose it's been designed for, which is there's a lot of maturity in the Java ecosystem that's not available in the Erlang and Elixir space, and that will change over time. But take HBase for example. The official HBase client that ships with the HBase distribution, it's maintained by the core maintainers of the HBase project, and it has a lot of, how do I put this, undocumented smart client logic that would take a lot of work to replicate in other languages. And people have tried, and people do, but it's a constant catch-up game, especially because it's not particularly well, the client itself isn't particularly well documented. So Jinterface is a great opportunity to leverage a library that is being maintained by a core team and is mature, and still work with it from our favorite VM environment and our favorite language, Erlang and Elixir. Okay, so diving into an example, this is how you would create an OTP node and create a process, and then send a message to a remote node and wait for a reply to come back. So these types are pretty straightforward. They're pretty self-explanatory. The only one that's quite interesting is that the developer of the Jinterface library decided that they wouldn't bother to call it an OTP process. They just call it a mailbox, because that's really all a process is at the end of the day. It's a mailbox, runs in its own thread. Well, in Erlang world as a process, but in Java land as a thread, and it's there to receive messages, and it's a FIFO queue. So you can build up using these OTP Erlang objects to build up the kind of message that you want to send, and then you wrap it in a tuple at the end so that you can send it down from the mailbox to the remote node. And in this case, at the very end, this ping string here is a registered process named string, named ping on the remote node. So that's the kind of mechanism used to send messages. Some notes about Jinterface. It can be used to communicate with only Java nodes. So you could actually pull together, you'd run EPMD yourself, and then you can actually use the Erlang distribution protocol from Java land to connect together Java nodes in this, homogeneous mesh network that you get with the Erlang disk configuration, and then communicate between nodes. One thing that you don't get with the Jinterface is it won't start EPMD for you. This is something that you get when you're working with the Erlang VM and you're starting a named node. You'll end up with EPMD being started in the background for you. This doesn't happen with Jinterface, so you've got to remember that it has to be started separately. So if you've got some kind of boot scripts, or you've got some sort of Ruby Chef cookbooks and things like that, then they'll need to make sure that they start EPMD before you can use Jinterface. It doesn't support everything that's available in OTP. That's not really surprising because it's a different VM environment. It'd be a lot of work to replicate a lot of that technology over into Java land, and even then you wouldn't really get the performance you'd like because they have entirely different concurrency models. It's very verbose to marshal types, and that's just a fault of working with Java objects. And now that I'm used to pattern matching as a way of destructuring data and working with structured information, structured data, I find it extremely tedious to work with, but it's just a consequence of the type system in Java. So it's not, the code itself is actually very verbose, but it's not complex. It's just a lot of type marshalling as far as I've come across with the Jinterface. And I can probably work on tidying that up maybe in the future with some sort of utility library at a more high level than what you get with the Jinterface API. Finally, there's a trace option that you can supply to the JVM when you're using Jinterface to enable you to watch messages that are sent between EPMD and between nodes as a way of tracing the information going on there. And you can set different trace levels, and level 4 is the maximum you can set it to. It's very, very handy when you're debugging things, when you're working with a JVM and a Java node connecting to Erlang land. A small bit of information about distributed Erlang. I'm not sure how familiar everybody is with distributed Erlang, so I just put this in anyway, just to allow people to get a quick overview of how that all works in case you're not familiar with it. So nodes must be named to become part of a distributed Erlang cluster. The cluster is loosely connected, so there's no such concept of master-slave or any kind of priority levels within the cluster. So all nodes are equal. The nodes are connected in a mesh network with exceptions. The exception is in the case of Java, and in fact you can configure this yourself with certain types of Erlang nodes as well. You can start with called a hidden node, which means that you only want this node to be available to a specific set of other nodes. You don't want it to be available to everyone in the cluster. So it's not going to gossip with everyone else in the cluster, only those that you want it to communicate with. And this can be really useful because in this case with Diver, for example, when I'm communicating with the Java node running the HBase client, I don't want that node to be dealing with all of the other network overhead and network gossiping of information with any other nodes connected to that Erlang node. I only want those two nodes to communicate with each other. So that's where hidden nodes come in. And there's more information. I've got a bunch of links at the end of the document that you can use to follow in more detail about the distributed Erlang setup. Finally, a cookie, not really any form of security, although you'll read that if you read the Erlang documentation. It simply decides which nodes are allowed to communicate with each other. So nodes that you want to connect together all need to share the same cookie name. That's pretty much it in a nutshell. Finally, the Erlang port mapper daemon. We'll have a quick look at this later when we do a bit of demo and code walkthrough. But this is a C program that gets started separately to the VM instance, but will get auto-started by the Erlang VM if you set up the node as a named node. And it maps symbolic node names to machine addresses. So it's a registry, basically. And the only other thing to remember about it is that it handles the work of allowing nodes to communicate with each other on the same machine or on remote machines by making them aware of each other. And that's what its job is. It's a very small C application, actually. And again, you can see the source code in the OTP releases and on GitHub, where you can find it on the OTP Erlang project. And yeah, it removes it for a specialized RPC framework. So if you're used to building things like, I know that in Netflix open source code and in Twitter, there's a whole bunch of projects to do with creating these generic RPC servers that can communicate with each other and send data and execute remote function invocation and give you back responses. A lot of that just becomes unnecessary. I mean, it could do with some work. You might end up doing some work to maybe decide on a different serialization protocol depending on your needs, but for the standard case, it's OTP. It's more than adequate. Okay, a little bit about the Diver project itself and a little bit about HBase. So HBase, not sure how familiar everybody is with it, but it consists of a number of different types of nodes that are connected together in a cluster, and involves both zookeeper coordination and what we call region servers, which manage data nodes. And together that makes up your HBase cluster, and you've got your HDFS layer sitting below that, which is actually managing the distributed file storage and replication work for data redundancy in the background. So if you want to find out more about HBase, there's loads of material online, and you can read more about it on the book that's available, the Apache book that's available on their website. What's important here is with this project, I'm not using the official HBase client. This is mainly because the surface area of that client and the API for that client is in quite a bit of constant flux, and I wouldn't describe it as particularly stable. So instead, I chose to use the other most popular client in Java, which is called Asynchbase, which is built by the OpenTSDB, Open Time Series Database team. They built this specifically for their needs because they build a layer of technology on top of HBase for handling time series data. So I'm using Asynchbase rather than the official HBase client, but they have almost the same feature set, although the Asynchbase client does everything asynchronously, and there's nothing in the client that's blocking. The only way you can block if you need to is you can flush calls to ensure that any queued up messages on the within the client buffer are flushed to HBase before you proceed any further. Okay, so like I mentioned before, it creates a Java node as a hidden Erlang node. Requests are dispatched asynchronously directly to the Java node, and responses are returned directly to the calling process in the Erlang side of the system. The Java node itself is monitored by a supervisor and restarted as necessary. And this is quite an interesting way of managing any type of interface you have to an external system you want to be able to keep alive and bring back up if when it goes down, and leverage that kind of supervision control that you get in OTP. Okay, so the rationale. So writing a HBase driver is a completely native kind of Erlang Elixir driver is very, very hard. You're going to have to replicate all the coordination logic with Zookeeper. There's the messaging protocol itself, which is based on protocol buffers to retrieve data. You have to copy any of the other undocumented client logic that I mentioned before that's in the official clients. And then you've got to do a lot of work to performance tune it and benchmark it. And finally, you'd need a very large test suite to keep up with the changes that happen upstream in the main HBase project, because they're still not on a 1.0 release, so they're happily going in and changing things. Having said that, instead, if you're able to build on a client like Asynchbase or if you want to take on the burden of the maintenance work with their official client, then you get all of this work for you. You just need to find a way to interface to it, and that's the direction that I chose with the project so far. There are a few alternatives, just for those of you that are interested in the HBase world in more detail. You can run a thrift gateway to the cluster, and this works reasonably well. The Thrift protocol, it's a very similar binary protocol to protocol buffers built by the Facebook team, I believe, originally. I think it's now an Apache project. Alternatively, there's Stargate, which is a REST gateway for HBase. Now, I don't know what the failure semantics of these types of servers are, but you are effectively introducing a bunch of middleware in between your database cluster, which already has its necessary fault tolerance embedded in it with the consensus algorithms that are leveraged from using Zookeeper and coordinating that state and ownership over different regions of data. Introducing in front of your HBase cluster, I'm not sure how you can guarantee availability there. Maybe you round robin between a couple of instances of those servers. I'm not sure, but it doesn't seem like a particularly how would I put it? I'm not sure it's a particularly well-favored approach, but it is available if you wanted to go down that path. And there is actually an Erlang client which I've linked to here, which will let you work with the Thrift gateway and works with HBase. So there is an alternative out there. Finally, let's look at some code, and we'll run through the code a little bit and play around with it in the IX shell, and you guys can ask me any questions you have. So, Chris, I'm going to switch over now. Let's see if this works. Okay, I'm going to stop screen sharing momentarily, and then go back over, and this time I want to share this view. Okay, can you see my terminal?
Yep, perfect. And then just bump the font up maybe a little bit. And
you need to bump it a bit more.
Yeah, I can't figure out how to enable the group chat, but Q&A is enabled. So
Okay.
Go ahead and ask questions in the Q&A, and then you can use other comments on the main event page.
Okay. Is that font big enough to easily read at the moment?
I'd say another 4 or 5 sizes.
Okay. Let's go with that. And okay, right. And if I switch between TextMate and my terminal, can you see me doing that?
Just terminal right now.
Just terminal. This is going to be annoying. Okay. All right, then. Okay, that's fine. All right, we'll switch to the code in a second then. Okay, so I'm actually in the Git project. It's open source. It's on GitHub. The link is in the PDF. You can follow along on GitHub if you like. Otherwise, you can always ping me afterwards or open tickets on the issue tracker or wherever. You'll find me in RSC as well. But what I'm going to do is let's start off by creating a named node. In fact, before we do that, one other thing, we're going to check that EPM. Cool, it's gone now. All right, so I'm going to set up my name node. Oops. And give it my cookie. We'll just give it that. And we're going to do mix run. Sake, I'm going to run it without starting the application. Okay, so we've got our IX shell, and if we go in and do ensure all started, we can see the diver app start. Okay, so the first bit that's interesting here is these two log lines. I'll show you in the code where they get written out, and what's happening here in the background is that the diver app is starting. It's starting a supervisor that's going to supervise one worker process, and that worker process is going to open a port and execute on that port a Java executable and pass in a number of command line arguments that we'll see in a second. So if we switch views for a second and have color, auto, and Java. Okay, so what's the interesting one here? It's this one. Okay, so what you can see has happened here is we actually have this Java process running. It's running with a bunch of command line arguments which we've passed in from the Erlang code, and I'll show you where that happens in a second. And then we do the usual jar flag, direct it to the jar file itself, which we store in the priv directory, the private directory for the OTP app, and then we pass it a number of command line arguments. So these command line arguments are used to start a Erlang, an OTP mailbox on the Java side, so the equivalent of an Erlang process in Java land, and then link those two, link the gen server process that we've used to start, that's in the supervisor that we've used to start this Java port, and then link them together so that we can do something like this. Kill the Java process, and then you'll see two more log lines, which is the supervisor restarting the process on the Erlang side, and then we run again, and we can see that we've got a new process. You can see by the ID here that the PID is different. So this is a new JVM process. So what's happening is the Erlang node is restarting the JVM process if it ever goes down. Okay, and that we don't have to worry about it. We can do kill-9 on it. It doesn't matter how that JVM process will crash. The Erlang node will restart it again. And this is our bridge between the Java node that we need to talk to HBase and the Erlang side that we want to actually query the data in HBase from. And by bridging them together like this, we know that if the JVM dies, then we just let the Erlang VM and the supervisor just spin a new one back up. The only thing to remember with this is the same semantics apply to the Asynchbase Java client as does the Java process we're running, the Java node we're running in Diver, which is that if we haven't flushed messages yet out of the client buffer onto HBase, if there's a backlog of messages and the JVM process goes down, then we'll lose those messages. But the same would be true if you were running it on a JVM app, or even if you were running the Erlang client, a native Erlang client of some kind, and you were buffering these client writes up before pushing them to HBase. So it's the same semantics that you need to be aware of when writing any data that you need durability guarantees over. Okay, so that's that. We'll just do one last thing. We're going to play with EPMD slightly, and we're just going to get the names list. We can see that there's two named nodes here. There's our original diver node, which is the IX shell that we're running here that we started our named node on. And then there is this other node, which what I'm doing at the moment is quite lazy. I just prefixed the node name from the Erlang node with this underscore underscore diver underscore underscore bit to give us a named node that we used when bootstrapping the OTP node on the Java side. So that's the way I'm doing that at the moment. Okay, so let's have a look at the code a little bit more. So I'm going to switch views now. Stop screen sharing. All right, and then let's switch it back on again. This time showing you code. All right, there's probably a more efficient way to do that, but it'll do for now. Okay, can you see my code, Chris? Yeah, you can. Okay, cool. Alrighty. So nothing particularly special here. Here's what we talked about with our worker process that we want as a child that the supervisor will.
Can you go ahead and bump your font up just a few points there?
Yeah. Is that better?
Couple more. We've got the space.
Okay, it's just in Java land we won't have the space, but anyway.
All right, well we can bump it down then, but yeah, there you go.
Yeah. Okay, cool. Yeah, so nothing particularly special here. The only interesting bit, I guess, is where we get these environment arguments from that we use to bootstrap the Zookeeper configuration that we need to tell the HBase client how to actually connect to HBase. And those environment variables are here. Okay, and what we also do is we actually have another set of properties here. It's just a list of binaries with information that we want to use to bootstrap the JVM runtime with. So the idea with this is that you can pass other, if you want to run, for example, a different GC strategy with your JVM, or you're running this in production and you want to mess around with the amount of memory that's being pre-allocated by the VM process, you can do all of those usual JVM tweaks by passing these arguments in here, and then, or in your own config.exs, and they'll get passed over when the JVM process starts. So all of that's nice, neat, and tidy, and these are actually the most important bits of information we need to tell the HBase client how to connect to the HBase cluster. So that's everything to do with this side of things. So let's jump into the Java code for a moment. Unfortunately, those of you not familiar with Java, it's a pretty verbose language, not something I can really get away from. So this is going to probably fall off the edge of your screens a little bit. I'll shrink it down a tiny bit, but we can always bump it back up again when we get to a different part of the code base. Okay, so we have our main method in Java. What I'm doing here is just basically providing a bunch of command line argument replacements, defaults basically, if I'm running this code just by running the jar itself without actually running it from the Erlang side. So I just want to make sure I can pass in a bunch of command line arguments or have a bunch of defaults to play with without having to constantly supply them on the command line when I'm doing my development work. But remember that all of these properties will be replaced by the Erlang, by the bootstrapping phase on the Erlang side. Okay, then after that, I'm not sure how familiar everyone is with dependency injection, but you've got your juice dependency injector that's taking this module, which has a bunch of configurations that we bind together, a bunch of properties, and nothing really special going on here. All we're doing is we're saying, give me back an instance of a HBase client and give me back an instance of an OTP node. And that OTP node is what we talked about earlier, is the Java node way of connecting to a distributed Erlang cluster, or a node in a distributed Erlang cluster. And the only thing we need to be aware of is if EPMD isn't running, we can't start it ourselves from the Java side, so we just need to bail out hard and bail out fast. So that's what that's there for. So once we've got our OTP node, we've got our HBase client, and they've been configured and they're able to start, then that work comes back here into the injector. We get an instance of our Java server, and we start it asynchronously, and then we block, waiting for it to be ready to do work. because if it's still bootstrapping, then we'll potentially be making a number of requests from our gen server side on the Erlang side, and we won't be able to handle those requests yet, so they'll just fall into a black hole. So we block waiting for it to be in a running state. And finally, this system out.println line is actually really important because it's what tells our Erlang gen server actually this port that we're communicating on has just given me back a standard out message that says I'm ready to go now. So let's have a look at the Java server on the Elixir side a little bit more. So remember, this Java server is being started here as a worker, okay, and it's just your typical gen server. And what we do, the most interesting part, I think, is first of all we look for the executable, Java executable on the system. If we can find it, great. If we can't find it, we might as well just bail out early. Once we found it, this is where I do that work of, taking our node name and prefixing diver in front of it to create the Java node name that will be associated with it. We do a bunch of work to get the name of the cookie, get the directory of the jar file that we need to start, a bunch of JVM arguments, nothing special here, and then we open a port. Okay, and we open the port, we spawn the executable with our Java process, and we basically pipe standard error to standard out, and we pass in a bunch of JVM arguments, and then we take the port PID that we get back, we create a strut that we're going to use as the state that we want to keep within our gen server, and we sync with Java startup. So this is where this ready message comes in. So what we're doing here is we're we're blocking on a message that we want to receive from standard out that is basically a message that's from the Java node saying, yes, I'm ready to do work here. And once we get that message back through, then we log to say that we were able to start the Java process, and we have to, okay, so at this point, what I would have liked to be able to do is do a node monitor operation and just basically say, well, I want you to monitor that Erlang node. Unfortunately, we can't do that because remember, this isn't a true Erlang node, this is a Java node, and that part of the OTP dist protocol isn't supported in the Jinterface library. So instead what we do is we create a registered process name that we've actually passed in at startup. Let me show you where it is. Here, this part of these arguments that we pass to the Java node, it's really nothing more than this registered process name. We pass that into command line arguments. That gets used to create an OTP mailbox. I keep calling it an Erlang process, but it's on the Java node. An OTP mailbox that we then can actually start sending messages to. So what we do is we send a message to it here, and we say, well, I'm giving you I need a process ID from you. So we get back a process ID. This is the Java node responding to us. We link that process together, and then we can monitor at that point. We can monitor the state of that node, and we can basically restart it if it goes down. And that's how we do all of that. That's to handle all the bootstrapping stuff and restarting the Java node if it goes down. So we need to do that monitoring and that process linking. So that's everything in the Java server. After that, we basically have some Java code to look at. And the most important bit is the startup phase. So at startup, we create a mailbox with this registered process name that we passed in as a command line argument to the Java node at startup. And then we get ourselves into the run state, and we basically receive. We put ourselves into a loop, and we wait for messages that come into the mailbox, and once we receive them, we pass them to a method called handle, and then we basically defer handling of that particular OTP message, another function, method in Java land. And this is, as you can see, mostly type marshalling. But what actually happens in this handle So first of all, in the handle phase, we start doing some destructuring of the message, and we basically look, it's either a gen server call that we expect, or it's a stop message, so we need to stop the client and stop the JVM process, or it's some other message that we don't understand, so we might as well just throw an error and say we don't know what this message is like, and we don't know how to handle it. If we can handle it, we pass it to our handle call, and we basically take the atom, which is the first element in the tuple, and that gives us the type of message that or the type of operation we want to execute on the HBase client. And depending on the type of operation, we execute different calls to the HBase client itself. Those calls happen asynchronously, so what we have to do is add something called a callback, which is a particular interface we have to conform to in this particular HBase client library. And we pass in the process and the information about the person who requested, the process that requested that message or made that request. And so we can actually send a response back to the calling process. And this is how we bridge messages back and forth between the Erlang side and the Java side. So let's see how that works in practice. So remember, we have our Java node running, and it's running there fine. We basically put together our gen server call, and we say that I want to talk to a registered process, and I want that process name, well, I know that process name is, and the node name is this.
Chris, can you, so we're still seeing TextMate if you want to hop back over to your terminal.
Ah, thanks for reminding me. Sorry, I have to keep switching them over. Oops. All right, go back into terminal. All right, can you see that?
Waiting on it here. Oh, there we go. Yep, we're good.
Okay, cool. Okay, so we got our gen server call. We're passing in the necessary structure to send this message to this remote node.
And then can you bump up font size a little bit more? I've got the space for it.
Yeah. Oops. Is that okay?
That'll work.
Yeah. Okay. So we make a gen server call, and in this case, we're going to pass in a message that I know, and you'll see in the library, we can't handle that message. We don't know what to do with that message. So we see almost instantaneously, we get this response back, this log message saying unrecognized message ignored, and obviously our gen server call fails. And this is fine because we tried to perform, we tried to enact a message, send a tuple to the Java node that it didn't know how to handle and didn't understand what to do with. So now let's send something that it doesn't know how to handle. So let's try this again, but let's do the client stats call. And for simplicity's sake, on the Java side, I've chosen to wrap all of these messages in tuples. So we send that, and we get this response back, which has basically been a message that we sent over the distributed Erlang protocol to the Java node. It came out of the mailbox on the Java side. We did all the type marshalling work. We realized it was a client stats request, and we want to know information on what the client is in the process of handling, operations it's done so far in the lifetime of the client. And this is just a particular feature of the Async-based client that I've exposed. And then we marshal that information into Erlang types that we can serialize and send back to the Erlang node, and then we get this information in on the Erlang side. So that's how we stuff in a nicer API, so you could just quite as easily have called client stats there, and we're communicating. But at this point, we're actually talking to the HBase client, but we're not talking to the HBase cluster yet. So HBase cluster, and we're going to do an ensure table exists. Okay, so you typically do these kind of operations in the startup of your application to verify with the HBase cluster that some sequence of tables that you need that store that you need the schema in place before you can start retrieving data from HBase. So we make this call, and we start a huge amount of output, which again is coming back to us over the port, and our gen server request fails, obviously, because it times out. And what's happening is here, we're seeing a bunch of messages coming back from the Java server that's basically it is unable to reach the HBase cluster. Okay, and that's fine because we haven't actually started HBase. So if we come over here and we start HBase and let HBase boot up, switch back over, give it some time for the threads, the thread pool running in the HBase client to pick up the fact that the HBase cluster is coming online. Give it some time to settle. All right. Okay. So now if we make this equivalent request over again, we get back a message. And so what's happening here is the HBase cluster in the HBase client in the Java node has a thread pool of connections that is opened to the HBase cluster, ready to carry out operations on the cluster. And we're actually communicating, sending gen server messages to the Java node. It's executing those HBase operations, serializing the response back, and shipping it back over to us. And all of that's happening, well, as fast as you can see. And if there's one other thing we could do here. In fact, I'm not going to do it now because Visual VM will mean I'm going to have to keep switching between screens with you guys again. But I could show you, maybe we'll do it another time, show you the Visual VM instance with the Java node, actually visualize the running Java node so you can see when messages are coming into it and actually executing HBase requests. But for now, you can see that that's actually working. So if we jump into the HBase shell, okay, and I can't remember it, the syntax for it, but HBase help. How do I create table from the shell again? I can't remember how to do it from the HBase. That's better. Okay, we switch back over. Oops. Oh yeah, we need one column family. Okay, so we created our HBase table. We can check that the table exists, and we get ignore the log message. I'm going to do better work at hiding some of these log messages, but we get back an OK tuple which says we successfully verified that that table exists in HBase. That's pretty much everything I've got really with this talk. I'll switch back over to the presentation. 1 second.
Gotcha.
And wrap it up. So one last slide for you guys. Future work. I would love to finish implementing everything that's in the Asynchbase API and handle that so that you can actually communicate with it from the Erlang side. Handle the scanner interface, scanning as a way of reading large sequences of data out of HBase. I'd like to do that by implementing it as part of a stream protocol using some of Elixir's protocol wizardry. But I need to figure all of that out in more detail first. Improve error handling, slim it all down a little bit, and benchmark it. And then, yeah, then it should be a production-ready HBase client with a little bit of work to improve logging output. Yeah, so that's everything from me, Chris.
Cool, awesome. So I just had a question as far as I don't have too much experience with ports, but do you see that as like a bottleneck with the client, or like do you need to worry about running, multiple ports and kind of pooling those, or do you think I know you're still waiting to benchmark, but as far as performance goes with a single port, is that enough so far to kind of keep things nice and speedy?
It's a good question. So, as far as I can tell, the um, as far as I'm aware with the design so far, what happens is that the port is used to manage the JVM process that gets bootstrapped, the operating system process. But all of the messages that go through the disk protocol through that port into the JVM, the Java node that's connected as part of the distribution. The bottleneck here is probably likely to be the like fake gen server portion on the Java side, long before it's a problem with the port, to be honest with you. And at that point, I'm not sure how best, as you say, you could potentially pool it with a bunch of JVM processes, but then they fight for, I mean, you end up getting IO bound as they fight for network resource anyway, communicating to HBase. So it's stuff worth benchmarking and figuring out later, I think. But yeah, it's less likely to be the initial bottleneck, but it could be one, definitely.
Gotcha, or not? Yeah, I was just curious. Cool. Yeah, well, I think what people can find it on your GitHub
On
account,
GitHub.
right?
Yep.
And yeah, this is looking super cool. And where else can they find you online if they want to get in
Yeah.
touch?
So I'm on RC most of the time anyway with as Novabyte. Otherwise, I really don't use Twitter very much, but I could get better at using Twitter. I do get the emails about it. So if you tweet at me, I can start checking those emails and do something with it. But I can get back to you for sure. Otherwise, I'm also on the Elixir mailing list and the Phoenix mailing list as well. So you can always find me there. So I catch
Cool.
all of those threads. Awesome.
All right. Well, I
Okay.
appreciate yeah you showing this out to us. This should be posted online, available on YouTube pretty soon. I might try to cut out some of the glitches getting started, but
Yeah.
sorry about that. Thanks for taking that in strides, Chris. Believe it or not, this was a
Yeah.
pretty smooth Hangouts experience compared to the past. But yeah, we should be back. I think yeah, sometime next year. So sometime in January, we'll try to get something else lined up. And yeah, this was really cool. Thanks a lot.
Awesome. Thank you. Yeah, no, I'll always listen into all of these anyway. It's really great to do them over Hangout. Makes it super easy to keep up with, even if I'm on a London time zone. So that's cool.
Cool.
Alrighty.
Yeah. Well,
Thanks,
I'll see
Chris.
everyone over at IRC then. So
Yeah.
see you later.
Take it easy. Bye.